Pretty much as you're a kid, you always want to be the strongest, you know what I mean? I always want to be the strongest guy. And I still want to be that, you know what I mean? Take it up, shut!
In 1959, my father showed me a book. It was about the Russians taking testosterone. So I said, well, what the hell, you know? First chance I get, I'm going to do some of this. And so I did. I've actually been on anabolic steroids for 36 years.
Is it something I should be morally battling, or like, should I be fine with doing it?
Your morals are your morals, not mine. Who am I to judge you? And who are you to judge me?
They are amongst the world's most controversial drugs, not coke, heroin or crystal meth, but anabolic steroids. Millions have used anabolic steroids, including those that you least suspected. No drug has been so reviled yet so misunderstood. Anabolic steroids is banned in many countries, yet millions of people are still using it illegally. Physiologists believe that steroids can push the physiological limit of a muscle, making it bigger, faster and stronger than it could get naturally. Hence, in this presentation, a dedicated team of final year Monash students will explore the dynamics, kinetics, mechanisms, adverse effects and abuse of anabolic steroids.
Anabolic steroid is the drug which mimics the effect of testosterone in human body.
And now we're going to give you a brief preview of their structures. Testosterone is a simple steroid that is produced in the gonads. Its structure is as follows. We have a methyl group at the C10 position and the C14 position. An example of an anabolic steroid is called nandrolone. Its structure is as follows. As you can see, the difference is the methyl group lacking at the C10 position. That is the main difference between testosterone and this particular anabolic steroid. As you can see, the difference between testosterone and an anabolic steroid is the addition and removal of alkyl and aromatic rings from its structure.
Now we'll explore how anabolic steroids interact with the human's physiological response. Would you like to explain how the pharmacodynamics works, Arvin?
Sure. I have one proper animation to show.
Steroid hormones are not water soluble. They travel in the blood attached to protein carriers. When steroid hormone arrives at their target cell, they dissociate from their protein carriers and pass through the plasma membrane of the cell. Some steroid hormone binds to specific receptor proteins in the cytoplasm and then move as a hormone receptor complex into the nucleus. Other steroids directly travels into the nucleus before encountering their receptor protein. The hormone receptor protein, activated by binding to the hormone, is now able to bind to specific regions of the DNA. These DNA are known as the hormone response element. The binding of the hormone receptor complex has a direct effect on the level of transcription at the site. Messenger RNA, mRNA, is produced, which then codes for the synthesis of the specific proteins, as shown.